Here we have a problem which says solve for dy dx on f of x. Okay, our f of x equals to 2 over the square root of x plus the square root of x over 4 plus 1 over x. Okay, I think I can rewrite it in a way that you can see. So f of x equals to 2 over the square root of x plus the square root of x over 4 plus 1 over the square root of x. Okay, first thing that we have to do over here, we want to organize these algebraically to make it easy for us to take the derivative. So in organizing it, I will say, so you should know that a square root is, let's say, let me show you this. So a square root of x equals to x to the power 1 over 2. So you should already know that on the exponents. Actually, it was on the exponents and radicals. So if it was, let's say, the cube root, let's say we have 3 over here, the cube root of x, then our x will be x to the power 1 over 3. And then if it was a fourth root, etc., etc. So a fourth root, it's when you have 4 over here, then you have x over here. That will be equals to x to the power 1 over 4. Okay. Now, this one over here will say 2 divided by x to the power 1 over 2, as I had shown over there. Okay, plus x to the power 1 over 2 divided by 4 plus 1 over x to the power 1 over 2. Okay, now we're not done yet. So anything that is having a fraction, and on a fraction you have the numerator and denominator, but if your variable is in the denominator, you have to bring it up to the numerator, and then when you bring it up to the numerator, only its exponent will change signs. So if it was negative over here, it goes up there, it will be positive, but because it is positive now, it will be negative over there. So that will be equal to, and when that variable goes up there, it will multiply the 2. So we'll have 2 x to the power negative 1 over 2. Okay, and then plus, now this one is not a variable. So what we do, we say, okay, we take 1 out from that x over there and divide the 4. And then we say that multiplied by x to the power 1 over 2. Okay, plus, now this one has to go up there, and then when it gets there, it multiplies by the 1. So it will be like x to the power negative 1 over 2. Okay, now we're ready to take the derivative. So we will say derivative of y with respect to x, or dy dx, would be equals to. Okay, now remember the algorithm that we use. the algorithm that we use would be n times x to the power n minus 1. So meaning that we always want to find out, like, okay, what is the exponent? And so when you get the exponent, that exponent will subtract 1 here, and then that exponent will come up in front. That's what this means. So now our exponent is negative 1 over 2. Then here we have a 2. We take that negative 1 over 2, multiply it by the 2 over there. Okay, so we say negative 1 over 2 times 2 times, don't forget, negative 1 over 2, okay, this is the part of the n over here, and then minus 1, that's the other part. Okay, that is in the exponents. Okay, so now we say plus 1 over 4. Okay, we're going to take the 1 over 2 over here. We say multiply by 1 over 4. Then x to the power 1 over 2 minus 1. Okay, and then that's the second term over there. Now let's get to the third term, plus. Okay, that will be minus. It's fine. We can use a bracket. Plus minus 1 over 2 times x to the power minus 1 over 2 minus 1. Okay, don't get lost. Stay with me. Okay, now it's a matter of like doing the math. Okay, negative 1 over 2 times 2 will be negative, because the 2's will cancel each other, negative x to the power. Okay, what is negative 1? Negative 1 over 2 minus 1. Okay, let me do it over here. Negative 1 over 2 minus 1. That's the same as negative 1 over 2 minus 2 over 2. Okay, believe me when I'm saying this. But if you don't, you can go back to where I was teaching exponents. I dealt with this, how I have 2 over 2 over here if it's a 1 over here. Okay, now when it's like this, it's a matter of doing the math. Minus 1 minus 2, it's minus 3. And then on the denominator, you just take that number that's on the denominator, only one of the 2's, you just say 2, negative 2 over 3. So now, over here, we have negative 3 over 2. Okay, and then now we're coming over here. Over here, it's 1 times 1 is 1, 2 times 4 is 8. So we're going to have 1 plus 1 over 8. Okay, 1 over 2 minus 1. Now, what is 1 over 2 minus 1? We do the same thing as we did over there. 1 over 2 minus 1. But, as you know, 1 over 2 minus 1, you should know that it's negative half, because if you take a half and you minus a full thing, it will give you a negative half. But let's do the math. That will be 1 over 2 minus 2 over 2. Okay, and then that will give us 1 minus 2, it's minus 1. Okay, and then our numerator is 2. So the answer is negative half. So over here we have x to the power negative 1 over 2. Okay, so on this, we're going to have negative, because plus times negative is negative 1 over 2 x to the power negative 3 over 2, because this is the same as that. If that was equals to negative 3 over 2, this would be negative 3 over 2. You don't have to redo the math. You already did it. 3 over 2. Okay. All right, we're getting somewhere now. Okay, now this is the answer. But sometimes we need to do things mathematically correct. So a mathematically correct way of doing this is when the exponents should never be negative. So you take the exponents where they are going to be positive. So this 1 negative 3 over 2 will only be positive if it's 1 over. So here we're going to have our answer negative 1 over x to the power 3 over 2. Okay, plus. Okay, this one we already have an 8 over there, so it's just going to say 1 over the 8 times this. Then we bring this one down then to be positive. So my plus 1 over 8x to the power 1 over 2. Okay, and then minus 1 over 2x to the power 3 over 2. So this is like now it's in the numerator, and then when you bring it to the denominator, it will change signs. And so that is called rationalizing your exponents. So this is our answer here. Okay, I wanted to do something quickly before I go, and then I think that will be enough for calculus, all these problems. But I wanted to show you something. So I have a problem which says solve f of x, solve for f of x. Okay, when f prime of x, when f of x equals to 3 cube root of x minus 64 fourth root of x. Okay, how would we do this? Okay, some of it I already showed you over here how you go about this. You start by organizing your f of x like this. Okay, it will be 3 times x to the power 1 over 3. This and that is the same thing. Okay, minus 64 x to the power 1 over 4. This is the same as that. Okay, now you are ready to take the derivative now. So you say f prime of x equals to, you take this 1 over 3, you multiply it over here, 1 over 3 times 3. Okay, x to the power 1 over 3 minus 1. All right, and then minus 1 over 4 times 64 x to the power 1 over 4 minus 1. Okay, so now these 3 and 3 will cancel each other, will be left with 1. So we'll have our answer as x over here, 1 over 3 minus 1. How do you do that? Okay, you do the same thing over here as I showed you, 1 over 2 minus 1. So this one will be 1 minus 3 because it would be 3 over 3 here. 1 minus 3 is negative 2 over what? Over 3. So we're going to have negative 2 over 3. Okay, this is the first one. Okay, then minus. Okay, how many times does 4 goes to 64? I think it goes 16. Yeah, it goes 16 times. So we're going to have 16 here. Okay, and then x to the power 1 minus 4. What is it? 1 minus 4 is negative 3. So we're going to have negative 3 over 4 here. You can, if you can't believe what I did over here, you can go back here and do the math. So when you do the math, you'll realize that what I did was correct. So now that would be the answer over here, but we're not done. I like to put things in a good way. So just take the x and put it in the denominator, and then the exponent will change sign. So we have 2 over 3. Okay, minus 16 over, okay, now it will be 16 over the x, 3 over 4. Okay, this is the correct way of putting the answer. All right.